Hi, welcome to the video on basics of ensemble techniques. By the end of this video, you will be able to understand what ensemble is and why it performs well. Combine different models to generate better predictions and explain the advantages and the disadvantages of ensemble models. So far, we have seen some basic machine learning algorithms. In the next video, we will look at some ensemble algorithms. Let us first understand the concept of ensemble through a simple example. Let's say you want to buy a car. Now would you go directly to the showroom, ask the salesperson about the best model and purchase it? No, right? You would research online, visit different sites, check the price range and reviews for different models, etc. You would also discuss with your family, friends and colleagues about their opinions and ideas or suggestions as to which car you should consider buying. Then you would go to the showroom and talk to the salesperson about the different models that he has. And finally you buy a car. So here you research, check the reviews, take into account the opinions of different people before reaching a conclusion. That's the broad idea behind ensemble. Instead of using a single model, you can use a group of models. Based on the predictions of each model, you can make the final decision. Now the question is, how do we combine the models? If all of these models make different predictions, how do you select the final value? We hope you are now familiar with churn prediction simple data. Here are the first few rows of the dataset. As you can see, we have a bunch of features like current month debit, previous month debit, current month balance, etc. and a target variable churn, which has values 1 and 0. Now using these features and the target, we can build multiple models on this data. For now, say we build 3 models and each of these models gives us a unique set of predictions. Suppose these are the set of predictions from model 1, model 2 and model 3 and for the given IDs. Now the problem is, how do we combine these different predictions for each row so that we have only one overall prediction? Any guesses? We can take a mode or we can say vote. Please note that we can use the term mode and vote interchangeably, so don't get confused. If all the 3 models predict the same thing, then there is no issue. Otherwise, the class that is predicted by most of the models, also called as the majority class, will be taken as the final prediction. This technique is called max voting. So, for the first row, we can see the vote can be 0. So a single model 2 would have predicted incorrectly, but combined models actually predicted the correct value. Now for row 2, model 1 would have predicted incorrectly. Similarly for row 3, model 3 would have predicted incorrectly. In the fourth row, model 1 was actually correct, but the vote resulted in an incorrect prediction. But that's okay. We never say that a combination of models would give 100% correct predictions, but it would be better, right? And for the last row, all the models gave the same prediction. So that will be the vote value. But this voting technique would work with classification problems where the target variable is discrete. Now suppose we have a regression problem with continuous target variable such as housing prices dataset, as you can see here. Similar to the previous problem, we have a bunch of features and a target variable. But as said earlier, in this case the target variable is continuous and not discrete. And now when we build multiple models and predict the values, those values are also continuous. Here we obviously cannot take the vote of all the models. But each prediction is unique. So what should we do in this case? Instead of taking vote, let's go with mean or average. So we add the values and divide by 3. This new technique is called averaging. So these final values are closer to the actual values, which means that the error should be less in this case. The ensemble models often lead to a better solution than any individual model. But they have both pros and cons. Let's take a look at the pros of the ensemble models first. When we have multiple models working together to explain the data, they are collectively able to capture most of the diverse signals or patterns underlying in the data, which is often missed by the single individual model on its own. Next, as each individual model only captures a subset of the underlying pattern, Each of these individual models are diverse in nature. As a result, their combination leads to less incorrect predictions. Next, as ensemble models consider the collective predictions of the diverse models, this reduces the overfitting effect of the individual models. Lastly, ensemble models have secured their place in the data science competitions, considering they have proven their performance time and again. Now let's move into the cons of ensemble models. As we are building several models and combining them leads to increased complexity. Also, these ensemble models are not interpretable as a whole. This leads to a black box predictive model, which is often not encouraged in domains like business and finance, as they expect models to be interpretable. As we are building several models for the singular purpose, the time complexity and the computational requirement increases significantly. Now that we have understood the basics of ensembling and how it works, we will now look at one of the most popular ensembling techniques called bootstrap aggregation or bagging in the next topic.